Hi class, welcome to your lesson 16 video. This is your pre-recorded lesson since we're not meeting live today. The good news is that it is not going to be an hour. It should be pretty short, like a half hour, just enough to kind of teach you the lesson so that we're not falling behind. Any questions that you have, I can answer them next class. We'll do a few do now problems next class of what we kind of learned today. And you can also email me if you have any questions. So here we are in lesson 16, and you can title the top of your paper. We're going to be talking about today simplifying trig expressions. And this is a really short kind of lesson. We really only spend one day on it. We don't spend longer than one day on it. It's kind of like in preparation for what we're going to call our sum and difference formulas in our next lesson. Working with these formulas for sum and difference, there's a lot of algebra, a lot of PEMDAS, and you have to get comfortable simplifying the trig expression once you use the formula. So we're going to do some practice with simplifying these trig expressions. Now, the last time we met, we did go through a cumulative review of everything that we learned in marking period 1. So when we're picking up here with simplifying trig expressions, this lesson, maybe I should put here, lesson 16, this is the lesson that would kind of start your next assessment, okay? So, the next assessment may be on 16, 17, 18, and 19, or 16, 17, 18, whatever. But my point is, this lesson is when you're gonna see questions from this lesson on your next assessment. That's what I want to say. So just a quick review of PEMDAS, right? It's actually funny with, everybody calls it PEMDAS. It's also known as the order of operations. It's something that mathematicians just kind of, agreed to. We all agreed to simplify expressions and equations in this format. If you can remember, your P stands for parentheses. There's a few different ways that you can spell parentheses. Let's see if Ms. Marflack, I'll use the ESE. Sometimes you see it with an I. Parentheses, but not only parentheses, it also means grouping symbols. So, you're used to seeing parentheses like this, but it can also be brackets. It could be something called braces. Any type of grouping symbol. The next letter stands for exponents. So it could be anything, any expression that has a square to it, or, anything, maybe I won't put the 2 on the outside because I just want to model the exponents, anything like this. Okay, that would be exponents. Now the next, I actually like to write multiplication and division on the same line. So Ms. Marflack's going to edit this. We do multiplication and division at the same time. They're both like on equal footing. And when you work with multiplication and division, you go left to right. So it doesn't matter, maybe the division comes first if it's on the left. So you may be doing division before you do multiplication, but when you get down to multiplication and division, they're kind of on the same line here, and you go left to right. And then we have our A and S, and that's our addition and subtraction. I put a slash for multiplication division, so we're going to keep it going with that slash. Addition and subtraction. And once again, just like the multiplication division, you are always working left to right. So if the subtraction comes first, left to right, that's what you're going to be doing. All right, let's jump in and take a look at an example. And maybe even before we get started on an example, I really want to advise you to get out that pink paper. You're going to need it, and it's going to be super helpful. Ms. Marflack's going to put some notes up here. I'm going to start with our 2 special right triangles, which I write kind of over and over again, and you should have that on your pink paper, that pink graphic organizer. So here, 1, root 3, and 2, and then this is 45, 45, 90. This is 1, 1, root 2, and then the last thing we kind of need is that very quick bare bones unit circle that just have our quadrantal angles on it. So that's what we're going to put here. That's supposed to be a perfect circle, but really paying attention to the coordinate points here, 1, 0, 0, 1, 0, just kidding, negative 1, 0 over here. See, Ms. Marflack almost made a mistake, and 0, negative 1. Okay, now we're ready to get started. So maybe that gave you enough time to kind of go looking through another tab or pause this video and please, please, please get out that pink paper. There's going to be a lot of things on here. Let's take a look at the first example, and our directions are going to be to simplify. And let's switch over to the black. Simplify. And we're going to start off here with number 1. And we're going to be simplifying sine of 3 pi over 2 times tangent of, let's see, pi over 4 plus cosine of negative 5 pi over 3. Okay, this is a lot, right, guys? I know we did problems that kind of looked like this, but we did it just with quadrantals, and now we have a lot more going on. Take your time, go slow, and use the graphic organizer. Please pay attention to this video the best you can, and if you're starting to feel like you're zoning out at any time, pause it, go do something for 10 minutes, and come back to it, okay? I need your absolute focus here. So the first one is sine of 3 pi over 2. Well, I'm looking at 3 pi over 2, and 3 pi over 2 is a quadrantal angle, which means I'm using the definition that sine is my y-coordinate, right? My y-coordinate at 3 pi over 2, here's 3 pi over 2, and my y-coordinate is negative 1. So this first value here is negative 1. Now, even though you don't see it between the sine and the tangent, there is this multiplication sign. There's nothing there, and when there's nothing, it means multiplication. Now we're taking a look at tangent of pi over 4. Pi over 4 is not a quadrantal angle, so we're going to be using our knowledge that tangent is opposite over adjacent. Look at all the little work that I'm going to do under tangent, okay? Use that unit circle and remind yourself that, you know, pi over 4 is in quadrant 1, where tangent is positive, and the reference angle is pi over 4, which is 45 degrees, and tangent is opposite over adjacent. So that's the method we used in class, right? What quadrant, positive or negative, what's the reference angle, and then give me the exact value. So I'm in quadrant 1, tangent's positive, 45 degrees, opposite over adjacent. So let's go to our 45-degree triangle, and let's take a look at opposite over adjacent. Opposite 45 is 1, adjacent 45 is 1, and you're just going to get 1 here. So tangent of pi over 4 is 1. And then now you have this big addition sign. And now you're going to be doing cosine of negative 5 pi over 3. So negative 5 pi over 3 is not on our unit circle, right? So we're going to take a second, and we're going to take negative 5 pi over 3, and we're going to add 2 pi, which is 6 pi over 3. So maybe Ms. Marflack will put over here in our notes. Remember, 2 pi over 1. If we have a denominator 3, like in this example, that's 6 pi over 3. If we have a denominator 4, in a future example, that's 8 pi over 4, and if we have a denominator 6, that is 12 pi over 6. So use these notes. Please use those notes. So here we are, negative 5 pi over 3 plus 6 pi over 3, and negative 5 plus 6, that's pi over 3. So this is like working with cosine of pi over 3. Pi over 3. All right, and then cosine of pi over 3. Pi over 3 is in quadrant 1, where cosine is positive. The reference is, once again, use that sheet that gives you all the notes, that 30 degrees is pi over 6. 45 degrees is pi over 4. And we're looking now at pi over 3, and we can tell in this chart that that is 60 degrees. And then cosine is adjacent over hypotenuse. Let's go to our 60 degrees. Adjacent is 1, hypotenuse is 2. So we're going to be adding plus 1/2 here. This is where the PEMDAS kind of comes in. So we evaluated sine 3 pi over 2, we got negative 1. We did tangent of pi over 4, we got positive 1. We did cosine of negative 5 pi over 3, and we got positive 1/2, positive 1/2. And then from here, we're going to go ahead and we're going to multiply first. So negative 1 times positive 1 is negative 1. And then now we're doing negative 1 plus 1/2. It may be helpful to get a common denominator, like this is negative 2 over 2 plus 1/2. And negative 2 plus 1, and that's going to be 1/2. All right, so that was like a lot of work for one problem, am I right? That was a lot of work for one problem, and we're using a lot of different things here, really focusing on that PEMDAS, and also working with that unit circle and finding the exact value. All right, I'm going to move on, and let's take a look at another one. And, you know, it's okay if at first this is kind of tough. I don't think it's easy. Keep in mind that we're going to do this a little bit in the next lesson too. Okay, we're going to do this a little bit in the next lesson. All right, we're going to keep it going with our directions to simplify. All right, we're going to do those directions, simplify. We're going to want to use that over here. And we can get rid of this. I don't need this. And we're going to take a look at number 2. And let's see if we can move some of this stuff. We're going to move this over here, right next to our notes. We'll move this right next to it. We'll move this next to it, and we'll move this over here. And that gives me kind of a lot of room to work with some practice problems here. Okay. Honestly, I kind of like working with this iPad a little bit more than I like working with the Xypeboard, so we might be using it in the future. Might be. All right, let's take a look at number 2 here, and we're going to do sine of pi over 3, tangent of 3 pi over 4 plus cosine of 11 pi over 6 and then secant of pi. Ooh, that's a long one too. That's a long one. All right, let's get started here. So I know you can use a unit circle, but I'm going to do my best not to use it. So we're going to go here. We're going to look at this first one. Pi over 3 is in quadrant 1. Where sine is positive, and the reference, I could take a look at pi over 3. My reference for pi over 3 is 60 degrees. So this is 60 degrees. And then I know sine is opposite over hypotenuse, so you can use the pink paper for that. And then we're going to go to our 60 degrees, and we're going to do opposite, which is root 3 over 2 over hypotenuse, root 3 over 2. Now we have this multiplication here, and we're going to be doing tangent of 3 pi over 4. 3 pi over 4 is in quadrant 2. Maybe you have to scan the unit circle to see where 3 pi over 4 is. It's in quadrant 2 where tangent is negative. The reference angle is pi over 4, and you can see over here pi over 4 is 45 degrees. And tangent is opposite over adjacent. So we're going to go to our 45 degree triangle, and we're going to do opposite over adjacent, and that's going to be 1 over 1, and it's negative, so that's going to be negative 1. So we did sine, we did tangent, we have a plus here, and we're going to do cosine. Cosine of 11 pi over 6. 11 pi over 6 is in quadrant 4, where cosine is positive. Reference angle is pi over 6, which is 30 degrees, and then cosine is adjacent over hypotenuse. Adjacent over hypotenuse. So now we're doing cosine of 30 degrees. Adjacent is root 3 and hypotenuse is 2, and it is positive. And then the last one here is secant of pi, and secant of pi, I'm looking at pi, I know it is a quadrantal angle, and secant is a reciprocal of cosine, so this is going to be 1 over x. So when I go to pi, my x value at pi is actually negative 1. So 1 over negative 1 is going to be negative 1. Okay, from here is where the algebra can get a little tough. But I want you to know that, use a combination. To get to this step, it could take you a little longer than it takes me. You're not going to have a lot of problems for homework. You'll probably have like 6 or 7, I won't overload you with them because you're really doing like 4 exact values in one, right? But you can use your unit circle. We're trying to stay away from it, but check your work, take your y coordinate at pi over 3. You should see that's root 3 over 2. And then, take your x coordinate at 11 pi over 6. You should see that is root 3 over 2 and so on. All right, now it's time to work with the algebra. So root 3 over 2 times negative 1 is just negative root 3 over 2. So I'm combining these two. And then same thing over here, root 3 over 2 times a negative 1 is just negative root 3 over 2. And now I have negative root 3 over 2 plus a negative root 3 over 2. This is where stuff gets tricky for some of you guys. I know just the algebra is tough. Remember we talked about combining like radicals, right? So I have a negative root 3 and a negative root 3. Altogether, I have negative 2 root 3s. And then when we add fractions, the denominator stays the same, right? When I do 1/4 plus 2/4, I add across and I get 3/4 and the denominator stays the same. Same thing here. I'm adding in the numerator. I'm doing negative root 3 plus negative root 3 is negative 2 root 3s altogether. And then I have 2 in the denominator. And then I can divide by 2 and I get negative root 3. I know these problems are tough, guys. I know it. but we're going to do our best. We're going to take our time, and we're also going to see this in the next class period. So don't give up on me just after the first example problem. Keep watching this video, stay focused, and the more practice you get, the better and better you get at it. I was impressed with our marking period 1 review. You guys remembered a lot of things. People were seeming more and more comfortable with radians, and it was really confusing a month ago, and now it's feeling better. Well, we're going to be spending a while on doing stuff like this, so you have to keep working hard, okay? I just want to end that saying that I know number 2 is tough. All right, let's take a look at another one, and I'm going to erase here. This would be a great time to pause if you don't have this one down, because I'm erasing it. Bye, number 2, goodbye. All right, we're going to take a look. I think we're at like 15 minutes now, about halfway through, and we're going to take a look at another one. Let's take a look at 3. Let's do here cosecant of 3 pi over 2 times secant of 4 pi over 3 times cotangent of pi over 4 times sine of 7 pi over 6. Ooh, so no addition in between with this one, right? This is just all multiplication here, all multiplication. All right, let's jump in, and we're looking at cosecant of 3 pi over 2. Well, the first thing you should recognize is 3 pi over 2 is a quadrantal angle, which means I'm working with the definition of cosecant as 1 over y. That is on your pink paper. And then I'm taking a look at my little bare bones unit circle, and I'm seeing, 3 pi over 2 is over here, and 1 over y is 1 over negative 1, which is negative 1. All right, so my first exact value, cosecant of 3 pi over 2 is negative 1. Now we're doing secant of 4 pi over 3. Okay, 4 pi over 3 is not a quadrantal angle, which means I'm going to have to use the method what quadrant, positive or negative, and so on. So you should be scanning that unit circle. Where is 4 pi over 3? It is in quadrant 3. Hopefully you see it. In quadrant 3, tangent and cotangent is positive, secant is negative. The reference angle is that denominator there, pi over 3, which is, let's see, where's pi over 3? Oh, it's right over here. It is 60 degrees. That's on our pink paper. And then secant is hypotenuse over adjacent on that pink paper. So let's go to our 60 degrees, and let's do hypotenuse over adjacent, and we make it negative, okay? Now we're taking a look at our cotangent of pi over 4. Pi over 4 is in quadrant 1, where cotangent is positive. The reference is pi over 4, which is 45 degrees, and cotangent is adjacent over opposite. I know I'm flying through that. If that takes you triple the amount of time it takes me, that's A-okay, okay? Pause the video and try it out for yourself. All right. Adjacent over opposite, we go to 45 degrees. Adjacent over opposite is 1 over 1, and it stays positive. And then we have the last one. If you wanted to cheat and look at the unit circle and figure out the y-coordinate 7 pi over 6, you can do that. Or I prefer us to do this, right? Quadrant 3, where sine is negative, the reference is pi over 6, which is 30 degrees. And we're going to do opposite over hypotenuse of 30 degrees, and that's going to be negative 1/2. All right, we got a lot of multiplying here. Maybe let's do a little bit of simplifying here. This is like negative 1 times negative 2 times 1 times 1/2. Maybe do these two first. Negative 1 times 2. Negative 1 times negative 2 is positive 2. And then maybe you can do these two. 2 and 1 is 2. And then you can do these two now, right? Sometimes people get confused, right? 2 times negative 1/2. This is like 2 over 1. So when I multiply straight across, I get negative 2 over 2. And that's negative 2 over 2. And that's going to be negative 1. So, right, a lot of work here for what seems to be a simple answer, but it's not simple at all. A lot of work. Look at all of the work we're doing with finding the exact value, right? Finding the exact value. All right. Hopefully you have number 3 down, and let's take a look at the next one. Take a look at the next one. I can use a bigger one here. There, that looks good. All right. Number 4. Right, number 4. Do I want to do that one? Ooh, those look really tough. We'll have to do those next class. Let's do this one. Cotangent of 3 pi over 4. Cosecant of 5 pi over 6. Plus cosecant of 11 pi over 6. And then sine of pi over 2. All right, so 2 multiplications and then an addition here. Let's jump in and get started. Cotangent of 3 pi over 4. Ooh, 3 pi over 4. Well, that's in quadrant 2 when I scan my unit circle. And maybe I should have put up this All Students Take Calculus a while ago. But I'm assuming that we're using our, graphic organizer. It's on the pink paper, but I'll put it up here. In quadrant 2, right, I have the big S, which means sine and cosecant is positive. So cotangent would be negative in quadrant 2. The reference angle is pi over 4, which is 45 degrees. And then cotangent is adjacent over opposite. So let's go to 45 degrees. Adjacent over opposite is 1 over 1, which is 1. And my answer is negative. All right, let's take a look at the next one. Cosecant of 5 pi over 6. I scan the unit circle and I find 5 pi over 6 at quadrant 2. Where cosecant is with sine, it's positive. The reference angle is pi over 6, which is 30 degrees. And cosecant is hypotenuse over opposite. So let's go to 30 degrees. Hypotenuse is 2 and opposite is 1. So we got 2 over 1. Big plus sign here. Now we're moving on to cosecant of 11 pi over 6. I scan the unit circle and I'm going to find 11 pi over 6 in quadrant 4. In quadrant 4, cosine and secant are positive. Cosecant is negative. The reference angle is pi over 6, which is going to be 30 degrees. Then let's go to 30 degrees and do hypotenuse over opposite and make it negative. Hypotenuse is 2, opposite is 1. That's going to be negative 2 over 1. And then lastly, we're at sine of pi over 2. And pi over 2 is a quadrantal angle, so I'm looking at the y-coordinate at pi over 2, and my y-coordinate at pi over 2 is 1. Okay, let's do the multiplication ones first. Negative 1 times 2 is negative 2. Big plus. Negative 2 times 1 is negative 2. And the negative 2 plus negative 2 is negative 4. So what seems to be a simple answer actually came from a ton of work in this step, right? A ton of work in that step. All right, I know I'm going quick, and I know we really don't have an opportunity to ask questions, but we're going to see this next class as well. So keep doing your best to keep up here, and at any time you can pause the video and kind of rewind, okay? All right, let's take a look at number 5. Number 5. Erase this. Yep. Okay, good. 5. What do I got for us? No, I don't want to do that one. Don't want to do that one. We'll do, okay, this one is a great one. This is a toughie. But we're in pre-calc. We can handle it. Cosecant of 2 pi over 3 plus sine of, let's not do that. Let's not do a negative angle. Let Miss Marflek leave it positive, so negative, so that'd be 5 pi over 4. And what's the last one here? Tangent of pi over 4. Okay, so the question is in black. All this kind of has to get moved over. I wish I could have fit it. Actually, let's try that again. All this I want to be moved over. Let's move that. Yeah. Okay, good. All right, so here is our question in black. And let's get started. Sine of 2 pi over 3. Okay, scan that unit circle. Find 2 pi over 3. You're going to see it's in quadrant 2. In quadrant 2, take a look at that graphic organizer. Sine is positive. The reference angle is at denominator, which is pi over 3. I can take a look at my pink paper, and that's 60 degrees, and then sine is opposite over hypotenuse. So we're taking a look at 60 degrees. Opposite 60 degrees is root 3, and hypotenuse is 2. All right, so we're done with the first one. The sine and the cosecant are joined through multiplication. So there's my multiplication symbol. And we're going to move on to cosecant. And it's the same information, quadrant 2, positive 60 degrees, because it's the same angle. And then at the end now we're doing hypotenuse over opposite. So I go to 60 degrees and my hypotenuse is 2 and opposite is root 3. Then big plus sign in the middle, and now we're going to do sine of 5 pi over 4. Scan that unit circle and find 5 pi over 4 in quadrant 3. Where sine is negative, the reference is pi over 4, which is 45 degrees, and we're doing opposite over hypotenuse here. Opposite over hypotenuse. Let me just squish this in a little bit better. 45 degrees and opposite over hypotenuse. So opposite 45 degrees is 1. Hypotenuse is root 2, and it's negative, so I got to put that negative somewhere. I threw it with the denominator. You could put it up in the numerator or outside the fraction. And then the last one, tangent of pi over 4, that's in quadrant 1 where tangent is positive. The reference angle is 45 degrees, which is pi over 4. And tangent is opposite over adjacent, and that's going to be 1 over 1. Okay, now it's time to multiply first. So we're multiplying these two first. Multiply those two first. 2 times radical 3 is 2 radical 3. 2 times radical 3 is 2 radical 3. And then 2 times radical 3 is 2 radical 3. Okay, that's nice. Plus. And then now here we are. We're going to get negative 1 radical 2. All right, because when I multiply by 1, I just get itself. And then now 2 radical 3 over 2 radical 3 is just 1. Right? Just 1. And plus a negative is just minus. Plus a negative is just minus. And now I do have to rationalize. So we can't have a radical in the denominator in our final answer. So we're going to multiply by radical 2 over radical 2. And I'm going to come up over here. And that's going to be, I still have the 1 in front, the minus radical 2, and now radical 2 is just 2. If you like, you can leave your answer like this, although this is really, it's really not technically simplified. You do need to kind of combine the fractions. I'll take it like that, but simplify really means combine fractions. So I need a common denominator, so I got to multiply by this 1 by 2 over 2. And then now that'll get me 2 over 2 minus root 2 over 2, and then 2 minus root 2 over 2, because I just subtract up in the numerator and I leave a common denominator. Okay, that's going to be it for today. Guys, I know this is tough. I know some of you are looking at this like, oh my God, I don't know how she got this. I don't know how she got that. I know it's a really tough lesson. You know, I told you the pre-calc would just continue to snowball. We have to keep using our graphic organizers and our resources to kind of help us get through these lessons. So I really need everybody looking at that pink paper, using all this information in red, you know, kind of up on the top. Your homework is only going to be a few questions. We did 5 together in class. Maybe I'll just keep your homework to 4 questions. Because, you know, each question has like 4 questions within it. Do your best. Take your time. Look, I'm the teacher and look how slow I'm going through this example, right? We've been doing a 30-minute lesson. We only did 5 examples. So you should be taking your time on your homework. We will see some more of this in the next lesson as well, keeping in mind that this is lesson 16, simplifying trig expressions, and lesson 17 will also be simplifying trig expressions. All right, get to work and then email me.